Hey guys, we are doing one more confidence interval. This entire chapter, we've been working on confidence intervals. We've done one where we had to find a z-score and then find the confidence interval for the mean. That was if we have samples above 30. We did one where we had to find a t-value and then find the confidence interval. And that is for samples that are below 30. We have done a proportion that would be percents, and we found that confidence interval. And today we are doing the chi-squared distribution, and that is for variance or standard deviation. So we find them all by doing the same type of thing, where we are finding a number that we are adding and subtracting the number from our either our mean or our proportion, or in this case, our variance or our standard deviation. The first thing that we have to do is we have to find our critical value. So before we begin, everyone's getting out their pink sheet, and you are going to look at the chi-squared distribution side. Some of you tried to do a t-distribution on the chi-squared. So one side is t-distribution, one side is chi-squared. We are doing chi-squared today. So the first thing that we have to do is it says find the degrees of freedom. And remember, the degrees of freedom is our sample size minus 1. And then we are going to find the area to the left, the area to the right, and then we are going to find our critical values. So let's do that. This says to find our area to the right or to the left is where we do 1 minus c divided by 2. Now, that is essentially where we did our standard normal curve. And if I'm looking for this, the 95% confidence, remember that this is my 95% confidence. Now, if my 95% confidence is in the middle, how much is left over? I can only have a total of 100%. So between these two tails, that means that I have 5% left over. So 5% divided by 2 is 2.5%. We've done this quite a bit with our z-score. And then if I take 2.5% plus 95%, right here is our 97.5%. Hopefully that sounds semi-familiar. That's essentially what this is, where we do 1 minus our confidence, find what's left over, divide by 2. We're going to get those two values. That's how we find it. So let's look at our first one. It says find the critical values for my right and my left for a 95% confidence interval. Well, my sample is 18. So my sample is 18. That means I have to find my degree of freedom is 18 minus 1, or 17. We did this when we did t-distribution. Don't ever forget to do your degree of freedom. We're going to be massively wrong. Then I have to find my find my areas to the left and to the right. So the area to the left, remember, when we convert this to a decimal, we divide by 100. So to the right is going to be 2.5% divided by 100, or 0.025. And we're going to take this value, divide it by 2, or divide it by 100 to get our decimal. I think I did my left and right wrong, but it doesn't really matter. 97.5, 0.975. So these are the two values we are looking for in our pink sheet. You're going to go to your pink sheet. You're going to notice that up above, it has all of my confidence levels where I'd need it. I need 0.975 and I need 0.025. That's why it doesn't really matter if it was the right or the left. So those are the two we need. Then you are going down to a degree of freedom of 17 and finding those two values. Those two values are 8.672 and 30.191. Everyone needs to be able to find this on their pink sheet. Those are my two critical values. So my x squared r is equal to 30.191, and my x squared L is equal to 0.95. Oops, I'm sorry. So I just want to point out why this is my right and this is my left. We're talking about the area to the right of this line here, which is why you use your 0.25. And we're talking about the area to the left of this line here, which is why you use that for your left side. So we found our areas to the right and to the left. That's all it's asking for the critical values. You use your pink sheet to find it. Let's do one more. All right. We have a 90% confidence interval. You can either choose to use this equation, totally acceptable, or you can draw yourself a picture. I want you to know how to get it in case you don't have this equation. But remember, we're going to have this pink sheet with us for the rest of the year. So you could always throw that equation into one of the margins. But remember, we are also going to use this for the rest of the year. So be thoughtful of the real estate that you're going to need. I am now going to use this equation just for my right and my left. My right is going to be 1 minus my confidence value, 0.9, and that's divided by 2. When you put that into your calculator, you get 0.05. Again, if I was to show the middle portion, 90%, you would say that 10% was left over. Divide that by 2, and I have 5%. And my L, I do 1 plus 0.9 divided by 2, and I get 0.95. Now, then we have to look at our degrees of freedom. So our degrees of freedom, we're going to take our sample size, 30, and subtract 1 from that. 30 minus 1 is equal to 29. So we are now going to look for our values that are associated with a degree of freedom of 29 and these two confidence levels. Again, we find our 0.95 and our 0.05 up at the top. We find our degree of freedom down at the bottom and follow them across. So hopefully you got your critical value of my right critical value of 17.768 and my left critical value is 42.557. That's all you had to do for the first two problems. Let's flip the page and see what's next. Now we're constructing a confidence interval either based on our variance or our standard deviation. So we are given these two equations. Variance is our standard deviation squared. So this is our standard deviation. This is our variance, depending on what they're asking for a confidence interval. So if we're finding it for our standard deviation, this is the equation I use. If I'm finding it for my variance, this is the equation I use. Notice here's my right and my left that we found. So it's really just identifying the numbers you have to put in to this equation. Tomorrow, we're going to go over how to identify which equations to use. This says you randomly select and weigh 30 vitamins. That is going to give me an N of 30. That's my sample size. The sample standard deviation is 1.2. So my S is 1.2. Also, since I just did my sample size, let's do our degree of freedom. Let's do our degree of freedom. My degree of freedom is 30 minus 1, or 29. Assuming weights are normally distributed, construct a 99% confidence interval for both the variance and the standard deviation. So my confidence level is 99%. The parameter, what goes with the population, is all vitamins. And the 30 selected is my statistic. Remember, parameter goes with my population. Statistic goes with my sample. We don't need to check our conditions, but we do need to find our left and our right. So we're going to do that. We're going to put it into our equation from the previous side. So my x squared r is equal to 1 minus my confidence level, 0.99, divided by 2. And that gives me 0.005. I am on Zoom. It's okay. Sorry, I had visitors. All right, so we found our right value. Now we have to find our left value where we have x squared L and 1 plus the 99% divided by 2. And I get 0.995. If you ever want to check your work, if you add these two together, they should add up to 1. Now I have to find on my pink sheet my critical values. So I'm going to do that by using my degree of freedom, 29, and these two values. So I'm going down to 29. I'm using the 0.995, this value, 13.121. And I have to find the 0.005, this value, 52.336. All right, now that I've done those calculations, it is asking me to find the confidence interval. That's what these are. Notice it's an interval. It's a group of numbers. We're going to find our standard deviation or our variance in between those two numbers. Find the confidence interval for both variance and standard deviation. So let's start with variance. Variance, I know because it's the sigma squared. So n minus 1, I'm assuming I don't have to do that, is 29 times my standard deviation squared divided by my right value, 52.336, is less than my sigma squared. All right. How's that? I'm trying. Which is less than, and I'm going to use the exact same numbers, 29 n minus 1 times my standard deviation squared divided by my left value, 13.121. Notice, same numbers on top. I'm dividing by a bigger number, so I'm going to get a smaller number. That's fantastic. That's my smallest number. And here, I'm dividing by a number that's larger than this one. So this side's going to be bigger, this side's going to be smaller. We're just putting that into our calculator. And you can put it into your calculator exactly the way that it's written. 29 times 1.2 squared divided by 52.336. Because it's being multiplied and divided, it doesn't matter what order we put it in. So I get 0.798 is less than my variance squared, which is less than, and then I'm again putting that into my calculator, 29 times 1.2 squared divided by 13.121. And I get 3.18. Now, that's my variance. Then, if I want to do my standard deviation, I'm just going to take the square root of both of those. If we look at this, it's the square root of the answer that I get here. And here it's the square root. So this is my variance. I know it's my variance because it says it's squared. I'm going to take the square root of 0.798. And it's going to give me a value of 0.893, which is less than my standard deviation, which is less than, again, I'm going to put the 3.18 into my calculator. I'm taking the square root of that. So the square root of 3.18 is 1.78. So what does that mean? It means that we are 99% confident that our variance will be between 0.798 and 3.18. And that our standard deviation will be between 0.893 and 0.178. So in order to do the chi-squared, you need to have the equation, and the hardest part is finding the critical values. And that is all I have. I didn't even give you a second problem to do. Today, you have some homework to do. You are welcome to work on your project if you finish with the homework. Tomorrow, we are going to review how to know which tests to use, because if you don't know which equations to put it into, it's zero helpfulness. And then Thursday, you will finish up your project. So I hope you guys have a fantastic day. I miss you. I would rather be with you than at jury duty, but I don't get to be. So have a great day, and I will see you guys Wednesday.